9.3, logarithm functions. What comes to mind when you read the title of this section? I want to see what you know. I couldn't use that as a homework question because we didn't have school technically on Friday, but logarithm functions, hopefully you've seen them or heard of them in other places. B to the y power equals x is written in exponential form because what do you see in it? An exponent. What's the exponent? Y. Log base b of x is y. Log base b of x is y. Say that with me. Log base b of x is y is written in logarithmic form. And yes, knowing how to say that is going to be a big deal because it makes sure that you know that base is the b. So base is the b of x is y. So it's going to a log expression will equal the exponent in an exponential expression. The argument in a logarithmic expression will be the answer to an exponential expression. These two expressions are equivalent. They mean the exact same thing, okay? I would practice this on your own. So on your own, can you, I guess we're down here anyway. Rewrite these into the other equivalent form. So base 3 to the power of 4 is 81. So I'm going to write log base 3 of 81, you can use parentheses if you want, equals 4. So a logarithmic expression will equal the exponent. Try to, come back and we'll check it. All right, on 2, log base 10 of 10,000 equals 4. I like to draw arrows, so it's base 10 to the 4th power equals 10,000. All right. Definition of a logarithm is in our book. So definition of a logarithm. So y is the logarithm of x to the base b, written as y equals log base b of x if and only if b to the y equals x. So we wrote the definition up here technically. Y is considered a log of x with base b. All right. So example 1, part A. The log of 512 to the base 8. So the log of 512, of is always for your argument, to the base 8. And what does that equal? So 8 to what power gives you 512? So we can just test out some different numbers. I know 8 squared is 64, but what's 8 cubed? 8 cubed is 512. So that means that this question mark is 3. The log of 512 to the base 8, or you can write it out or say it as log base 8 of 512. Of always goes with your argument. Base always goes with the tiny number down here, is 3. Part B is log base 8 of just 1/64. 1/64. So what exponent do I need to have so that 8 to the x turns into 1/64? Well, 8 squared gets me 64. A negative 2 will get it in the denominator. So x is a negative 2. There is no mathematical way to algebraically figure this out. This is simple, but you have to know what square roots do, what powers do, what do negative exponents do. It's logical, but there's no math to show the work. It's all in your head to think, okay, what is going to make this true? So rewriting it in each expression definitely help your logical thought, but is not the It's not a straightforward way. It's a way to think about it. It's not a straightforward way to go step by step to figure it out. All right, and then part C, still in example 1, is log base 8 of the 7th root of 8. So what exponent will get me the 7th root of 8? That's 1/7. An exponent that is a fraction is going to get me a root. Flipping the page. Example 2. Common logarithms. They are awesome. They're weird, but they are awesome. And I'll talk more after I finish this video with them. So the first one, find the logarithm of each number to the base 10. So you can write log base 10 of A, and A's number is 100. So log base 10 of 100. What exponent with a base of 10 gets you 100? 2. So the answer to A will be 2. I can also write this as just log of 100. Log base 10 is the common part, where everything used to be in base 10. Now our calculators can do a lot more, but everything was based in base 10. So if I had 132 as a number, I have, well, yeah, I'll continue with it. You have 2 times 10 to the 0 power, and 3 times 10 to the 1st power, and then you have 1 of 10 to the 2nd power. 10 squared is 100, so I have 100, plus 3 times 10 to the 1st, which is 30, and 10 to the 0 is 1 times 2 is 2. We are in a base 10 system, and that's why this works. Increasing my 10 powers as I go in a number is base 10. That's why I have tenths, hundredths, thousandths also in my decimals, because it works for fractions as well. Because I would then go zeros, I'd have plus 0 times 10 to the negative 1, plus 0 times 10 to the negative 2, etc. So this is all base 10. Everything is based on base 10, so a common way of writing logs is not writing the 10 part, because if you don't see it, it's going to be a log base 10 no matter what. All right, so then part B is 0.12341. So this is tenths, hundredths, thousandths, 10,000ths, 100,000. So this is 1/100,000th. So I want to know the log base 10 of this number equals what? So what exponent would I have to take 10 to get 1/100,000th? 10 to what gets me 1/100,000th? Well, it has to be a negative number because I'm making it in the denominator, and I'm adding on, so 10 to the 1st, 10 squared, 10 cubed, 10 to the 4th, 10 to the 5th. So it has to be -5. So 10 to the -5th will get me 1/100,000th. Should box the answers. All right, and then part C is 1 trillion. So 1 trillion, that's million, that's billion, that's trillion. Okay, so I'm going to have log base 10 of 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And so how many zeros did I add to it? 12. So I'm going to have to the 12th power. Because 10 to the 12th gets you 1 with 12 zeros. And the last one's part D is 10 square root 10. So this one's a little more complex. I want log base 10 of 10 square root 10. You can still write the 10. If that drives you nuts that it's not there, go ahead, write it. Just know that if I don't put it, it's always going to be base 10. All right. So we want log base 10 of 10 root 10 equals something. So we know that 10 times the square root of 10 is 10 to the 1st times 10 to the 1/2 power, which if you're multiplying with the same base, that's the same as 10 and 3/2. So this is actually the same as saying log base 10 of 10 to the 3/2. If these are the same base, then the answer is just the exponent on the argument. because 10 to the 3 halves is 10 to the 3 halves.